Describe a transformation that gives the graph representing G from the graph representing F. So when we talk about a transformation, we're simply saying, how did we have to manipulate one graph to get the other graph? Did we move it left to right? Did we move it up or down? Did we reflect it or flip it upside down? Did we reflect it or flip it sideways? These are the types of movements that we're talking about. So when we look at A, F is this graph on the right. G is the graph on the left. And we can see first off, these shapes seem to be very similar. It looks like all we did was move this graph from the right over to the left some. So what you want to do is find two easy to identify similar points. So what I might choose is this point right here, the x-intercept at 2, and then it looks like it corresponds with this point on G where the x-intercept is -3. So it appears that we shifted left, and if we went from 2 to -3, then that's 5 spots. So A appears that we shifted 5 units to the left. Now we can look at B. As we look at this one, the bottom graph is F, and they want to know what we did to get the top graph, which is G. And they've identified 2 points for us here. The first one at the peak, where it is 0, 1 on the y-axis, and the other where it is 2, 2 at the peak. So now if we look, the x value went from 0 to 2. So they're saying we shifted right 2. And then we can see the y value went from 1 to 2. So we shifted up 1. So shifted 2 units right, and 1 unit up. Now if we look down here at C, they want to know how we went from the top graph to the bottom graph. And one thing we can see is that it appears that we flipped the graph upside down, or we call this reflection. So the first thing it appears we did was reflect across the x-axis. We took this top graph that looks like a U and we reflected it down over the x-axis. Then, because reflecting it over the x-axis would have left the vertex here at the origin, it also appears that we shifted it up from the origin to 3. So first we reflect over the x-axis, then we shift up 3 units. Does the function f or the function g fit the data better? Explain your reasoning. So function f is this top parabola, and function g is this bottom parabola. And when they're asking which one fits the data better, you're asking which graph is more closely aligned to the points. So if we look on the right side, G appears to actually go through several of the points on the right side. F seems to go out to the right of these points. So on the right side, it appears that G fits the data better. Looking at the left side, we see that there's a gap between the points in both graphs, but again, it appears that G is much closer to the points than F is, because we can see this big gap between the top parabola and the points. So it appears graph G fits the data better because the graph is closer to the points than graph F is. Describe a way to transform each graph so that it goes through the labeled points. Now, when you're trying to describe these transformations, most of the time there are several ways that you could describe it. A is a really good one. I could just simply shift this graph left 2 spots, or I could simply shift this graph up 2 spots, or I could actually reflect this over the x-axis, and then this point, when flipped upside down, would go through the point, or I could reflect across the y-axis, flip this over from left to right. And if I did that, what we would end up with is kind of the mirror opposite. So you could choose any of these, such as reflect across the y-axis. But if you chose any of the others that I talked about, it could also be correct. B. You could shift this down. You could shift this right. Or you could even say this point is right on a crosshair. I see this point at 1, 1, or at 0, 1 as a crosshair. So let's say I wanted to take this point, which is my y-intercept, and I could say that I shifted down 1, and then I shifted left 1. There are lots of different ways that you could describe these transformations as long as you end up with the graph going through the new point that they want. C. Again, lots of different ways you could do this. We could shift this down 8, and we would end up going through the point. We could shift this down 4, right 2, and have the vertex at this point. Or we could reflect across the x-axis, and we end up with this parabola kind of opening downward and going through that point. And then this point would be the flip version of this. So we could say reflect across the x-axis. And on part D, the easiest way that I see this point right here, which if I shift it down 2 becomes this point, and then this point right here, which if shifted down 2 becomes that point. So the easiest here would be shift down 2 units. So we can say that we're shifting if we're moving it up and down, left or right. And we can say that we're reflecting across the y-axis if we're flipping it sideways, or reflecting across the x-axis if we're flipping it upside down. A pumpkin pie recipe says to bake the pie at 425 degrees Fahrenheit for 15 minutes, and then to adjust the temperature down to 350 degrees Fahrenheit for additional 45 minutes. The function p gives the oven temperature setting P of t in degrees Fahrenheit T minutes after the pie is placed in the oven. Number 1. Explain what P of 30 equals 350 means in this context. Well, we can see that T is inside parentheses and T is minutes after the pie is placed in the oven. So in this case, T is 30, so this means 30 minutes. 350 would reference 350 degrees Fahrenheit, So this tells us we want the oven temperature is 350 degrees Fahrenheit for 30 minutes. Number 2. Diego discovers that the temperature inside the oven is always 25 degrees warmer than the oven's temperature setting. The function b gives the actual temperature of Diego's oven. If P of 30 equals 350, then what is the corresponding point on the function b? So now instead of P of 30, we're going to have b of 30 because the time has not changed. What has been changed is the temperature. P of t told us it was 350 degrees, but now they're telling us the temperature is actually 25 degrees warmer. So if we add 25 degrees to the original 350 degrees, this tells us B of 30 equals 375. And then number 3, write an expression for B in terms of P. So we're going to take the function notation that we just wrote, and we're going to come up with the generic expression. So we want B of t, this will work for any time, that is going to equal P of t, which was the original temperature at any given time, plus the 25 extra degrees warmer that we know the oven really is versus what it says it is. So this function in number 3 would allow us to solve for any temperature B if we're given the temperature P that the oven shows. Describe a way to transform each graph so that it better matches the data. So what we're trying to do is move the solid line graph so that it falls in line with the dots of data that are plotted. So you want to look at your shape. A appears to have the same shape. It just appears that it needs to move up and to the right. So we want to pick some easy to identify points. You could do it here at the top of this peak, or you could do it at the bottom of this peak or trough. So if we take this bottom point here, then we would need to move it to match up with this bottom data point here. To do this, we're going to shift right from 1 to 4, which would be 3 units. Then we're going to shift up from 0 to 2, which would be 2 units. So we're going to shift right 3 units up 2 units. B. This appears if we want to move the solid lines to line up with the green plotted data points, then we need to shift these lines up and to the right again. We want to pick easily identifiable points. So one that I see is if we try to move this point right here at 1, 1 and have it align with these data points here at 3, 2. So first, we're going to shift to the right. We're going to shift from 1 to 3, so that's 2 units. Then we're going to shift up. We're going to shift up from 1 to 2, so that's 1 unit. So we want to shift right 2 units, up 1 unit. And now our lines would be right on top of the plotted data points. Now if we look at C, the line is opening upward. The data points, however, form a parabola that opens downward. So the first thing we're going to need to do is reflect across the x-axis. This will flip it upside down. So reflect across x-axis. Next, we're also going to have to shift. My graph has a vertex at the origin, but once I reflect it, I need to shift it so that it has a vertex at the point 2, 5. So we're going to shift right 2 units. Then we're going to have to shift up 5 units. Once we make these transformations, our graphs will align with the plotted data points. Here is the graph of y equals f of x for a function f. On the same axis, sketch a graph of g of x, which equals f of x plus 2. So we need to make sure we understand how we're shifting based on the graph. If we add outside parentheses, then we shift up. If we add inside parentheses, then we shift left. So on number 1, we're taking the original graph and we're shifting up 2, because what we're increasing by 2 is the value of y. So when I see this point right here at the x-axis, I am going to shift that up to y equals 2. Then my other x-intercept is also going to shift up to y equals 2. And my vertex at -4 is going to shift up to -2. And now I can draw my parabola. On number 2, now we're adding 2 inside the parentheses. And what this does is shift it left 2. So now what I want is I want my x-intercept that comes just before 4 to shift left and be just before 2. My other x-intercept that comes just before 0 needs to shift 2 to the left and come just before -2. And then my vertex that is just before 2 needs to shift over and come just before 0. So now I've shifted these 3 points, my 2 x-intercepts and my vertex, I've shifted them all left 2, and then I can draw the graph of my parabola. So now on number 3, how do the graphs of G and H compare to F? Graph of G is shifted two units up, while the graph of H is shifted 2 units left. You need to make sure you understand these shortcuts of looking at the equation and knowing what kind of transformation you have, because it's going to make all of this work moving forward in lessons and on your tests that much easier. I don't have to keep plotting points to draw. I know that if I add 2 outside the parentheses, I'm just shifting everything up 2. If I'm adding 2 inside the parentheses, I know I'm shifting everything left 2. I draw the same graph, but I draw it shifted the number of units and direction that I know I need to shift it. The thermostat in an empty apartment is set to 65 degrees Fahrenheit from 4 a.m. to 5 p.m. and to 50 degrees Fahrenheit from 5 p.m. until 4 a.m. Here is a graph of the function h that gives the temperature h of x in degrees Fahrenheit in the apartment x hours after midnight. The owner of the apartment decides to change to a new schedule, and they set the thermostat to change 3 hours later in the morning and the evening. On the same axis, sketch a graph of the new function g giving the temperature as a function of time. So, in this example, time is our x value and temperature is the y value. So now if we want the thermostat to change 3 hours later, then we're going to shift all of our points 3 units to the right. So we're going to move 3 units right at the bottom. We're going to move 3 units right at the top. Then we're going to move 3 units right at the top again. And then 3 units right at the bottom again. So now when we draw these points, we can connect them together to show the new graph. It comes over 3 units farther. Then we have our slope. It comes across the top and extends 3 units farther. And then we have our downward slope. And it continues over. So now we see the new graph, which just shifts everything over 3 units. Number 2. Explain what h of 6.5 equals 65 means in this context. That means it is 65 degrees Fahrenheit at 6:30 a.m. Why is this a reasonable value for the function? Because we can see up here on the graph, the point would be right here. We have 6.5, which is 6:30 in the morning, and we have 65-degree temperature because that is the temperature that the landlord sets the thermostat to for that time. So it's reasonable because it matches the description and graph. Number 3. If h of 6.5 equals 65, then what is the corresponding point on the graph of g? Well, we shifted everything 3 units to the right, so the corresponding point would be at 9.565. So the corresponding point would be g of 9.5 equals 65. And we just wrote it using function notation like they asked for. And number 4, write an expression for g in terms of h. So if we wanted to write g in terms of h, notice that when g of 9.5 equals the same h was 6.5, which is 3 less. So we would need to say that h of 9.5 minus 3, because 9.5 would be our x. So if we wrote this as a generic form, we would write g of x equals h of x minus 3. Because if we make x 9.5 in the example shown, then h was 9.5 minus 3, which was 6.5. This is why subtracting inside the parentheses actually does the opposite of what you might expect it to, because subtracting inside the parentheses actually shifts everything to the right by 3. Our final practice problem. The graph shows the height of a tennis ball t seconds after it has been hit. The function f given by f of t equals 5 plus 30t minus 32t squared models the height of the ball in feet. Number 1. How high was the ball when it was hit? Where do you see this in the equation? The ball is hit at time 0, and the height at time 0 is the y-intercept, and that height is 5 feet. So the ball was 5 feet above the ground, and we see that at the y-intercept. Suppose a second ball follows the same trajectory but is hit from 7 feet off the ground. Sketch the graph of the height of the second ball on the same axis. In this case, all we need to do is shift our main points 2 units up. So we shift the y-intercept 2 units up, we shift the vertex 2 units up, and we shift our endpoint 2 units up. And then we connect the points. And number 3, write an equation for a function g that defines the height g of t. So I want my equation to be g of t equals in feet of the second ball hit from 7 feet off the ground in terms of f of t. So g of t equals f of t, and our shift was 2 units up. If I shift 2 units up, I add 2 outside the parentheses. Okay, so adding outside parentheses shifts up, subtracting outside parentheses shifts down, adding inside parentheses shifts left, and subtracting inside parentheses shifts right. Make sure you remember these 4 indicators, and that will help you understand.